In this lesson, we're going to create pad stacks. There are several types of pad stacks. This particular pad stack right here is what they call surface mount. In other words, there's no hole in it. The component is simply a cylinder that gets soldered to this pad. This is also a surface mount pad stack. It's very, very small. Surface mount again, and these are the through-hole pad stacks. You see a hole, you see some copper, and you also see the solder mask. Now the solder mask is very important because they don't want the shorts to happen from the pad to the trace. Now these are all the traces that go from point A to point B. This is a square pad denotes pin 1. This also denotes that this is the front of the board, and this denotes the device type. Now most of the time they don't have this on the silk screen. In this case they did because they had enough room. This is called a reference designator. You will have schematics that will tell you that, for instance, pin 1 of U404 goes to somewhere else, and that would be denoted on the. In this case, they have added the surface mount devices first, which goes through a separate process. Then they will install the through-hole devices. That'll also go through a wave and get soldered. We are also going to make thermal reliefs, and this is a pretty good example of a thermal relief. Notice that this is copper. In other words, it's a big hunk of copper. There's no copper here, no copper there. And the reason for that is if we didn't have spokes, this pad will get cooled by the copper, which acts as a heat sink. And in order for the device to solder properly, you need a lot of heat here, and you don't want the heat to escape into this island of copper. So this is a thermal relief. Also, this one is a thermal relief. Many times we put them in a 45-degree angle, and we'll get to that when we go further into the lesson. And these, of course, are through-hole devices and surface mount devices which are not installed yet. Sometimes they install them or sometimes these parts are not going to be used on this type of a board. You can also note that sometimes a trace can be put in through the copper, and sometimes if this is ground, it prevents this from getting noise problems, and also keeps the signal nice and quiet. So let's go ahead and start making some pad stacks. First thing we're going to do is create a flash symbol, which is basically a thermal relief that we identified in the picture. And we're going to start in symbol edit mode. We're going to set some design parameters. We're going to create the thermal relief, and we're going to save this symbol to disk. Everything we talk about is in the PDF file that I supplied. This is Lab 5-1, creating a flash symbol. We're going to start the PCB editor using the Allegro PCB Designer, and the PCB editor appears. You're going to learn how to start the editor in previous labs. We're going to choose File New, very important, and if alert windows is displayed, click no, and we're not going to save the current design. The thermal relief that we are going to create is a TR8060, which means it's a 60 hole, 80 pad, and it is a thermal relief, and we're going to put 4 spokes in it. So here is a design. We just opened the PCB designer, which is the PCB editor. We go File, New. As you can see, boom. And the drawing name is going to be TR, which means thermal relief, underscore 80, underscore 60. And it gives you a list of things that you can create, which is a board, modules, package symbols, symbol wizard. We want flash symbol. We say OK. Okay. The next thing we're going to do is set up the design parameters, which is very easy. Choose Setup Design Parameters, click the Design tab, and you kind of want to make it look like this. The size is an A-size drawing, which is basically a regular sheet of paper, which this is, since this is in mils, it would be 11 inches by 8.5 inches. The accuracy can be 0, and the size will be A. So here we go. Follow my cursor to Setup, Design Parameters, and we have our design parameters. And we go to the Design tab. The size right now is C, but we want it just to be A. It's a very small, nonsensical part. Accuracy, they said 0, so we'll make it at 0. And we could, the extents could be a minus 2000, which is, that would be like 2 inches and 2 inches, which is fine. And we can see that it's 11 by 8.5. And the drawing type is flash, which is fine. And we're going to apply that. And OK. Now we're ready to create the thermal relief. Choose Add Flash from the top menu and fill out 60, 80, 15, 4, and spoke angle 45. Click OK, and then we do a zoom fit. So now we're back into our program. We go Add Flash. The inner diameter 60. Outer diameter 80. The spoke width, I'm going to make 15. Number of spokes 4. Spoke angle 45. And we don't need a centered dot, and I'm going to say OK. Now if you notice, we have a little something over here. This is actually our thermal relief. And it's small, and the easiest way to bring it up to see what we actually have is to do an F2, or I think it's this one, zoom fit. Let's try this one. So now it's fitting that little thing into our design. This is our spokes. This is free of copper, so that we have a very nice thermal relief that will hold the heat into this area here. And this is where the through-hole device will be installed. This is nothing more than a symbol that will go for the fab drawing, with the drill fab drawing, drill drawing. Sorry. The next thing we're going to do is save it. We just do a file, save as. And we already have everything in there. The only thing is we want to make it, we want to save it into our play directory. And our play directory is in the all basic right here. See where it says play. So we go there. And open and save. And we already have it there because we've done it a couple of times, so we just say yeah. One thing we should also say, right now it's writing to disk. Notice follow my cursor to this area here, it says the drawing is saved, but it has also created an FSM. And the reason for the FSM is that is actually a binary file that's used by the system. The drawing can be edited in any way. After you're satisfied with the editing, then you save it again and it'll create another FSM. And we'll expand on that a little later. So that concludes the thermal relief.